Hey there everybody, this is Andy from Zenith Game Development at TAMUC. Basically, so sorry for the late videos. I had some issues over the winter break getting paid and other complications with work, so I decided to stop recording these until I could start getting paid again and have everything be working out fine with paperwork and whatnot. Also, YouTube gives me a hard time. And so in last episode, we basically went over the basic player movement. You may notice that some of these project files are different from the last video. That is because I had to work on this current file for our live meetings because the other laptop was doing an update that took about 2 hours. So I had to basically delete some of the progress I had made in that file, or this file I mean, in order to get back to where we were on the second session. So basically, last episode we made the basic player with the collision shape, the sprite. The script is pretty bare bones right now. You just have tile size, the inputs, you set the position at ready, and when you press a key it moves in that direction instantly. And what that looks like is this. It's a little bit janky, but that's good. Like it works well. If your game is not doing this, you can always reach out to me on Discord or group me. Discord is preferred. I can also answer emails. And what we're doing today is we're going to add a little bit of animation to this sprite when it moves, and also we're going to be adding collision with the tile map. So the first thing we actually have to do to work on this episode is we have to add the tile map. You're gonna go right click on main, and then just put in tile map or tile, whatever. You'll see it down here. Double click that and it'll open up. And for now the tile map is empty. You can see right here on tile set. I pre-made an auto tile for us because auto tiling in Godot is a little bit tricky. So if you go to your assets, there's a tileset.tres, which tres means it stands for resource, and you can just drag and drop it, or you can click the load button and then load that file. And this just gives us the walls. Actually, in addition, you need to go to cell and set it to 16 by 16. This is just so it doesn't make giant tiles like you just saw. And you can set the quadrant size to 4. It doesn't really affect anything, but it does affect how these lighter gray lines look. And it should be good. We'll test that out. Right now, I think there is the possibility that our player will be kind of off the grid, if that makes sense. You see how it's in the center? We'll see real quick if that is the case. Yep. Okay, so what you do to fix this is, it's pretty simple. You just go click your player and then move it. Oops. I'm going to do this with my keys, my arrow keys. You just need to move it 8 pixels this way, 8 pixels to the right, and 8 pixels down. It will then should be in the correct spot so that you don't have any weird collisions. Yeah, just like that, where it's lined up with the tiles. Okay. Oops. So that's all you have to do for your tile map. I don't suggest much more than that. You can always play around with it if you feel like it, but I'm not going to go further into detail about it. Also, what I would do is I would go to your scene tree here on the left and drag your tile map to the top. This is because we want the player to appear over the tile map, and I believe I mentioned it in last episode that in Godot, the lower something is on the scene tree, it draws on top of other items, which is kind of goofy to me. I feel like obviously it would make more sense to put what's on top is printed or drawn on the screen on top of other items, but it's the opposite in Godot. And that should put us above these tiles. This is just for later on. You may have some issues and you may not know why your player isn't appearing on top of your tile maps, so it's just a thing to keep in mind. So what we're going to do today is we are first going to add the simple animation, which is done with a tween node. A tween stands for in between in animation. It's pretty self-explanatory. What a tween does is it interpolates between two numbers using a mathematical function. So if you go into your create new node, you want to attach this to your player. You're going to click tween. It can be anywhere in your player nodes hierarchy, and that's all you need to do in the scene tree. We're then going to add a basically a call to this node from the player. So our player script is obviously attached to our player. The player node has a child called tween, and we want to be able to access that from code. So what we have to do is there is a keyword that is used to to make a variable of one of our children nodes. And this is onReady var. And basically this loads up this variable as soon as the script is even loaded up. So it does it first before anything else. This just keeps it from, say you want to call your variable from unhandled input. If for some reason this variable up here doesn't load before this function, you'll get an error saying that variable doesn't exist. So that just avoids that issue. And we're going to call this variable tween because it's calling the tween node. And in Godot we have a keyword called, well, not a keyword, but a pre-made function called getNode. And inside this we're going to put the name of our node as it is in the tree, which it's just called tween. So we attach it as tween. Make sure the casing is correct. It is case sensitive. And then once we have that, we're also going to make a new variable called speed. And this is just going to be var speed int equals 7. And this is how quickly we want our player to animate, because the tween needs a speed of how quickly it is to perform the mathematical function on the two values. So you can have your player move really quickly or very slowly, depending on what you want to do. I chose 7 because I felt it was the best speed. I used to have it on 5 and then I had it on 10, and both were kind of a little too slow or a little too fast. So you can set this as whatever you want. I definitely encourage playing around with some of like this speed variable and seeing how it affects the animation if you'd like to explore a little bit with that. And so basically, instead of just moving directly here, we want it to call the tween, and the tween will move our character between the two values, which is basically where the player was before you hit a key and where the player should end up. And then it's going to interpolate, which means to smoothly animate. So what we're going to do is in unhandled input, we're first going to add a line of code, which is if tween, which is calling our get node, if tween is active. And isActive is a function that is native to the tween node, and it's basically checking if it is currently animated or animating. If it's not, then it will continue, but if it is, we are going to use a return statement. Oop, my bad. A return statement basically just tells the function to end. So instead of going to this code down here, if the tween is currently animating, it's going to return, and it will never reach any of this code. So once we have that, this line stays the same. This line stays the same also. And so does this one. And so the rest of this function stays the same, except we are going to change some things in our move direction function. So, instead of just having our direct change to the position, we are not going to use this line anymore, and instead, we're going to call a function called move tween direction. Now, move tween doesn't exist currently, so we do need to create a new function, which is move tween. And then we include our parameter, which is direction. Make sure to put a colon at the end. And I will get back to you as soon as I get my laundry from the dryer. Thank you. Okay, so your move tween function is just going to call our tween node and tell it what we want to interpolate between. This code is a little bit more complicated, I would say, not because what it's doing is complicated, but because you need a little bit more prior knowledge of Godot's pre-made functions and what type of math you want to do. We are not doing math, thankfully, but we are telling the function to do math for us. So what we're going to do is we are going to write tween, which calls our tween node. We are going to call the function interpolate property. And this is a pre-made function in Godot. And I will write this code and then I'll explain what's happening. So you're first going to write self, going to write position in quotation marks. Then you are going to write position, which is not in quotation marks. Then position plus direction times tile size. And then we are going to do 1.0 divided by speed, tween with a capital T, a period, trans sign in all caps, and then another tween with a capital T period, ease underscore in underscore out. So this is a lot here. Basically, these are parameters to the interpolate property function. The first thing we are saying is we want this interpolation to affect ourself. So basically the object that this script is attached to, which is our player. We want it to affect the property called position. This is basically, if you click on player and you look at transform, there's a value here called position, and if we hover over it long enough, it will show us the property name, which is position lowercase, and that's what we're saying to affect here, is that property. Basically, we're saying the value we are starting with is position, and the value we want to end with is position plus direction times tile size. So basically the value we want to start with and the value we want to end with. So obviously if we're moving the player, we start with where the player is currently and then where we want the player to go. We are then saying how quickly over a second is it going to do this. So 1 divided by speed, so 1 second divided by 7, so 1/7 of a second. And then we're saying what type of mathematical function we want it to use, which it's using transsign, which is of the tween resource. So basically transsign is a predefined function of the tween resource. These are all just keywords, so for properties Godot already has for us. And then we are saying the ease, and what the ease does is it says how slow or quickly at different parts do you want the object to move. So ease in out means that it is slowest, it is slowest at the beginning and the end, but the middle is like a steady speed, but it slows down a little bit at the beginning and end of the movement. I'm not sure if that makes complete sense, but basically we're saying move the player's position to the position plus direction times tile size in 1/7 of a second with a trans sign function, and the ease is going to be ease in out. That's what this line of code does. And if everything is working correctly, we should be able to see this in action. Okay. 1 second, y'all. Okay, I realized my problem. I actually had a typo myself. At the end of the move tween function, you have to say tween start. This just tells, so here you're setting the interpolate property that you want to happen, but then in order for it to actually start, you have to call tween start. That was my bad. We all make goofy mistakes, usually. And when you use your arrow keys, you will see that the character now kind of moves more smooth. Another thing we want to do is we want to tell the sprite, when we press a key, we want to tell the sprite to flip itself so that it looks like the character is turning. To do that, we go to player, we go into our for directions and input keys, and this may not be the most efficient way to do it, but what I do is if event is action pressed left, true, or well, you don't really need the true there because this true is only used to check if we want to hold down the key, which for this we don't need to check that. And so we say if event is action pressed left, so if the left key is pressed, we want to go to the sprite. I'm going to add a node call here. It's going to be to the sprite. So once again, we use onReady var sprite equals get node sprite. It's very simple. And then we can call that here. So we'll say sprite, and if we go to our sprite, and we can look at, let me find it. Okay, there's a property here called flip h. So if you hover over it, the property is flip underscore h. And if you click this, you'll notice that the sprite right here actually looks like it turns around because we're flipping the horizontal. So we're going to go flip h equals true. And then we're going to put another if statement that says if event is action pressed, and instead of left, we're going to do right. Make sure to include your colon. Sprite dot flip h equals false. And that should work. We'll have to double check because this is from memory and not my notes. There you go. So now you have the character which interpolates, making the animation more smooth, and when you go left and right, he turns around. So now we just need to add, I believe we just need to add collision. Hey guys, Editing Andy here. I got very confused while recording this video. I thought that in the last episode we had included collision because in my notes I didn't include collision in this episode. However, I do go through the collision, but I do say some weird things where I'm like, hey, if you already have this in your file, like, don't worry about it, just skip this part of the video because we did it in the last episode, but I'm missing it in my file. That's not true. We did not do it in the first episode. So all you need to do is follow along. I may go a little bit quick because I thought we did not need to do it in this episode, but I was wrong. So if you need to, just go back a little bit, watch it a few times. If it's too fast for you or I don't explain something very in detail and you don't understand what's happening, just message me on Discord and we can either do a video call or I can send you a message with a better explanation. Sorry about that, guys. Thanks. So apparently I made a mistake. I thought we had done the collision in this episode and not the last episode, and I deleted my code. I am going to very quickly go over this. If you already have your collision on your mouse, don't worry about it. This is just I messed up and I need to very quickly put this back in. Basically, you're going to go to your player, add a child node. We are going to add a Raycast, and a Raycast is almost like a collision shape, except the shape of it is a line. So we're going to click enabled. We're going to put cast 2. I'm going to just put 16 in the Y direction, so automatically it's pointing down. It doesn't really matter where you point it. I just like setting this 16 so that initially when you load up the character, the raycasting isn't super long or something like that. And we are going to add a call to onReady var raycast equals get node raycast 2D. And basically in move direction, we're just going to check if the raycast is currently colliding. So we're going to say ray.cast2 equals direction times tile size. And this is just telling the raycast to, oh, my bad, I'm going to rename this variable to ray, meant to, so that it matches right here. What this is doing is just telling the raycast to point towards our direction at the length of our tile size. So, and then we're going to say ray.force raycast update. What this does is it makes the raycast update in the same frame, because usually it would update on the next frame, but we don't want that because then it would take 2 clicks of a button until our character moves. If you like, you can comment this out by doing a pound symbol, and you can test that out and see how that works. And then all we have to do is make an if statement. So if not, the not is represented by the exclamation point. Ray dot is colliding, and is colliding is a pre-made Godot function for the Raycast node. Basically, if it's colliding with something, it will return true. If it's not, it will return false. And it always returns the first object it is colliding with, not all objects. So that's something to keep in mind if you use this in your own games. You can read the documentation on that. And basically, it's checking if it's not colliding. If the character is not colliding, then we can move. And that's it. Sorry about the Raycast mishap, but that should mean that we cannot walk into this object now. And we also animate. And yeah, that's all that we have for today's episode. This is where we got to and leading to. I will try really hard to get the next video out as quickly as possible. I know it's been a while and there are a lot of people who want to finish up their projects, especially those who were in the live meetings, because there's just about 30 minutes left on the last section of this game, which is loading your levels and determining a win state. And that won't take long. I just need to get up to that point in recording. So thank you so much for watching. If you have any questions, message me on Discord, group me, or email me. I will most likely answer more fast to Discord. You can also leave a comment, or not a comment, a message in the Programming Help Discord channel. If you go here and you go to Zenith, we have a Programming Help text channel, and you are more than welcome to comment here, and I or another programmer are probably more than happy to help out. I will also announce video uploads in the video upload channel. I will give a link to the most current video on YouTube. And all those video update comments will be pinned. So if you go to pin messages at the top right, Apparently this one is not pinned. I will pin that. And then you can go to pin messages and you will be able to find these video links quickly. I'll see you guys next time. Thank you so much for watching. I can't wait to edit this video. Thank you. Bye.